Hi, in this video we are going to discuss maps in Java. Map is a data structure which stores items like different data structures we already discussed, but how is it different? Map stores the items as the entries of key-value pair, so we have key and corresponding value. An example of a map general idea could be phone book, so we have keys represented as strings of first name and last name and corresponding values. While in general this can be a representation of some kind of a map, it is not an ideal example. Why? Because in real world we might have Thomas Edison multiple times, so we have multiple Thomas Edisons, multiple Taylor Swifts, but when it comes to map, it's an important constraint that each key must be unique. It should never be repeating. Like different data structures, map also has its implementations. One of the popular implementations is hashmap. Hashmap stores data in key-value pairs. This is typical map construct, and it allows single null key and many null values. And of course, hashmap is not synchronized, and if you are writing application which uses thread safety, and if you are using maps, then you should be careful because hashmap does not come out of the box as synchronized. Now let's see how hashmap looks like internally and how it works. So we can imagine inside hashmap we have the array, and array elements are called buckets, and each bucket is a linked list. And inside the linked list we have these nodes representing entries of the map. So each node will have key, which is an unique value, and each key, unique key, will have corresponding value, and we will also have hash. The hash value is calculated initially to efficiently store and retrieve the entries of map. And also we have this next, which is a pointer, and it is used to keep track of the nodes of the linked list. For example, now let's say we are putting an entry to the map and we have this key Tom and value 25. So initially we are going to calculate the hash value, and based on this hash value we are going to calculate the index. And based on this index it will be decided where the entry goes, in which bucket. So if the index is 0, it will go to 0th bucket, and so on. Next step is to put the entry in the bucket as a node. And finally, if the collision happens, add new node and link it. So what is collision? Collision is such a case when two different keys will produce this same hash value. For example, if we have key James and hash is 23, and we also have another key Tom and it has the hash value 123, same hash like before, in this case we will be adding new node and linking it to the previous one. So this is how collisions are handled. But we should note that in Java implementation it is very rare to happen collision, because implementation is written in such a way that occurrence of collision is down to a minimum. But of course it can still happen in some situations, and if it happens, this is how it is handled. Another implementation of map is tree map. So use case of tree map is that in certain situations we might need sorted order for map entries. And in this case keys will be sorted in natural order or by a custom comparator which we can write on our own, and we can write our logic based on which the keys will be sorted. And tree map is also not thread safe. Null keys are not allowed, and we can have null values. Another implementation of the map is linked hash map, and use case is when we need ordering for the map entries. And it allows one null key and many null values. And also it is not thread safe. Next implementation we are going to review is concurrent hash map, and it is a synchronized version. It is optimized for the performance, but it does not allow null keys or even null values. And concurrent hash map is considered a modern alternative of hash table, Hash table is a legacy implementation, and although it is thread safe, in general, in modern Java code, concurrent hash map is considered a better, more optimized alternative. But still, which one to use depends on the concrete, particular use case. Also, we have other map collections such as map implementations, such as weak hash map, which is used mainly by garbage collector in order to keep track to object references. And also we have identity hash map, which is comparing keys using equals operator. So why it is useful? In certain situations, we might want to compare two objects by their identity, meaning that we are comparing not the values of the object, but we need to know if they point to the same memory address. So in this case, we might need identity comparison, and we might find identity hash map useful. Of course, these implementations can be fit to many specific use cases, but this is just an overall idea, general examples of their use cases. In terms of time complexity, hashmap has on average constant time for getting, putting, or removing the items. And worst case is O log n, not O of n. And reason is that since Java 8 we have this improvement in hashmap, where instead of linked list, the entries will be turned into balanced binary tree. And as we know from our previous video, it was about sets. If you check it out, unless you have already watched it, there is time complexity analysis of balanced binary tree and how it offers us, in worst case scenario, O of log n instead of n time, and how it is much more faster. And in case of tree map, get, put, and remove operations on average take O log n instead of constant time. And reason why? Because tree map is sorted, as we know, and it is using balanced binary tree. And this is main reason why it is using why it has this time complexity on average. Now let's perform simple demo to use map in our Java code. So we are going to type map, and we are going to choose data types for keys and values inside this diamond operator. So let's say keys are of type string and values are of type integer. You hover your mouse over map and press Alt plus Enter. It will import map from Java util package. Let's call it map, and this equals to new, and we are going to indicate concrete map implementation. In this case, it will be hash map. Let's use it. So this is how it is declared. Now let's demonstrate put method. Put method is to add a new entry to our map. So I will say Tom, and I will say 25. Let's say key is first name and value will be age. Now let's do SOT, hit tab, and inside system out print line, let's print corresponding value of the key Tom. So this will be get method, and get method will take this key, which is in this case Tom, and it will retrieve corresponding value. So let's see what it does. If we run the program, on the output we can see 25 printed. So this is what we wanted to achieve. And this is just scratching the surface, because if you look at these methods, there are multiple possibilities. We can put, get, and also we have several methods to check if map contains certain key or value. We can also perform some iterations by transforming our map into entry set and looping through them. And there are many powerful methods and possibilities in Java maps. So you can discover them on your own, but this is just a general idea how map is declared and initialized. Now let's summarize what we did in our video. So we defined what is a map, and we reviewed map implementations. We observed internals of hash map, and we reviewed time complexities, and we compared specifics and use cases, why we should use one implementation over another. And also we performed short hands-on demo. Of course, this is just scratching the surface, just general idea about maps, but you can continue on your journey. You can use Java documentation for maps and discover more possibilities which you can use. So this was all about maps. Thank you for watching. I hope you liked this content. And if you liked the content, please give us thumbs up and subscribe. And I'll see you in the next one.